GTC 2023 Nvidia เปิดตัวโมเดลการคอมพิวเตอร์ AI ที่ปฏิวัติวงการ
We have a lot to cover with you today. GTC is where we talk about industry, science, computing, the present, and the future. So I've got a lot to cover with you today. But before I start, I want to thank all of our partners who helped sponsor this great event. You'll see all of them around the show. They're here to meet with you. And really great. We couldn't do what we do without all of our ecosystem partners. This is the Super Bowl of AI, people say. And therefore, every Super Bowl should have an amazing pregame show. What do you guys think about the pregame show and our all-star athletes and all-star cast? Look at these guys. Somehow, I turned out the buffest. What do you guys think? I don't know if I had something to do with that. Nvidia invented a new computing model for the first time in 60 years, as you saw in the video. A new computing model rarely comes about. It takes an enormous amount of time and set of conditions. We invented this computing model because we wanted to solve problems that general purpose computers, normal computers could not. We also observed that someday transistors will continue, the number of transistors will grow, but the performance and the power of transistors will slow down. That Moore's law will not continue beyond being limited by the laws of physics. And that moment has now arrived. Dennard scaling has stopped. It's called Dennard scaling. Dennard scaling has stopped nearly a decade ago. And in fact, the transistor performance and its power associated has slowed tremendously. And yet the number of transistors continued. We made this observation a long time ago, and for 30 years we've been advancing this form of computing we call accelerated computing. We invented the GPU, we invented the programming model called CUDA, and we observed that if we could add a processor that takes advantage of more and more and more transistors, apply parallel computing, add that to a sequential processing CPU, that we could extend the capabilities of computing well beyond. And that moment has really come. We have now seen that inflection point. Accelerated computing, its moment has now arrived. However, accelerated computing is a fundamentally different programming model. You can't just take a CPU software written by hand, executing sequentially, and put it onto a GPU and have it run properly. In fact, if you just did that, it actually runs slower. And so you have to reinvent new algorithms. You have to create new libraries. You have to, in fact, rewrite the application, which is the reason why it's taken so long. It's taken us nearly 30 years to get here. But we did it one domain at a time. This is the treasure of our company. Most people talk about the GPU. The GPU is important. But without a programming model that sits on top of it, and without dedication to that programming model, keeping it compatible over generations, we're now CUDA 13 coming up on CUDA 14. Hundreds of millions of GPUs running in every single computer, perfectly compatible. If we didn't do that, then developers wouldn't target this computing platform. If we didn't create these libraries, then developers wouldn't know how to use the algorithm and use the architecture to its fullest. One application after another. I mean, this is really the treasure of our company. CuLitho, computational lithography. It took us nearly 7 years to get here with CuLitho, and now TSMC uses it, Samsung uses it, ASML uses it. This is an incredible library for computational lithography, the first step of making a chip. Sparse solvers for CAE applications. cuOpt, a numerical optimization, has broken just about every single record. The traveling salesperson problem, how to connect millions of products with millions of customers in the supply chain. Warp, Python solver for CUDA, for simulation. cuDF, a data frame approach, basically accelerating SQL, data frame databases. This library is the one that started AI altogether, CUDNN. The library on top of it called Megatron Core made it possible for us to simulate and train extremely large language models. The list goes on. Monai, really, really important. The #1 medical imaging AI framework in the world. By the way, we're not going to talk a lot about healthcare today, but be sure to see Kimberly's keynote. She's going to talk a lot about the work that we do in healthcare. And the list goes on. Genomics processing, Ariel, pay attention. We're going to do something really important here today. Quantum computing. This is just a representative of 350 different libraries in our company. And each one of these libraries redesigned the algorithm necessary for accelerated computing. Each one of these libraries made it possible for all of the ecosystem partners to take advantage of accelerated computing. And each one of these libraries opened new markets for us. Let's take a look at what CUDA X can do.
Ready, go! Yeah!